This is also a good time to recap what we had learned about the potential energy of some arrangement of charges. The total potential energy stored in any arrangement of charges, say I had 4 charges arranged as I do over here, is defined to be the work done by us needed to take us from our reference configuration, which for charges is always just all the charges separated from each other out at infinity, and the work needed to take us from that reference situation where all the charges are far away here from one another, and move them into their present location. In this example, this little square of charges that I'm showing you over here. We then showed how that total work, we computed it by moving in charges here one at a time, first Q1, then we brought in Q2, then Q3, and finally in this example Q4, and we looked at the energy required at each stage of that process. To bring in Q1 required no energy. When we brought in Q2, it was only feeling the influence of Q1. That gave us this first term, Coulomb's constant Q1, Q2 over the distance between those two charges. When I bring in Q3, now you'll notice Q3 interacts both with Q1, which was there already, and Q2. So I have these extra interactions, Q1, Q3, and Q2, Q3. And in the diagram, I'm showing you what happens when we bring in Q4. And as you can see, as I bring in that Q4, the next terms we would have to add in here would be 4 interacting with each of the previous charges, 1, 2, and 3. And so we end up with a sum with a general pattern like this.